Good day, everyone. This is Dr. Recuenco for Platelets and Hemostasis lecture. So let's start with the video.
Hemostasis is the process that controls bleeding at the site of injury. Blood loss is stopped by formation of blood clots that seal the breaks in blood vessels. Hemostatic mechanisms involve small cell fragments known as platelets and a dozen of soluble clotting factors. These elements are always present in the blood in their inactive form, ready to activate, typically within seconds of an injury. When blood vessels are damaged, blood is exposed to components of the surrounding tissue. Some of these components bind to and activate platelets. Activated platelets are involved in all stages of hemostasis. First, they secrete chemicals that induce blood vessels to constrict, thereby reducing blood loss. This is known as vascular spasm, the most immediate response to tissue injury. Vascular spasm is also triggered by local pain receptors and by substances released by endothelial cells. Second, activated platelets become adhesive to each other and to the endothelium. They clump together, forming a platelet plug. They also secrete substances that attract other nearby platelets, activating them in a positive feedback loop, speeding up the formation and propagation of the plug. Third, the surface of activated platelets serves as the site for coagulation, the formation of blood clots. A clot is essentially a platelet plug reinforced with strands of a protein called fibrin, the final product of the coagulation cascade. Coagulation is a complex chain reaction where one clotting factor activates the next in the multi-step pathway. There are two activation pathways for coagulation. The extrinsic pathway starts with the exposure of blood clotting factors to the tissue factor, TF, in the extravascular tissue. This pathway is induced by injuries to blood vessels. The intrinsic pathway, which involves only factors within blood vessels, is thought to serve as a positive feedback loop, amplifying coagulation. The two pathways converge into a common pathway, producing thrombin and ultimately fibrin. Thrombin has the central role in the coagulation cascade. It cleaves soluble fibrinogen to generate insoluble fibrin. Thrombin also further activates platelets and initiates a positive feedback loop that is essential for clot propagation. Blood clots prevent blood loss during wound healing, but once the vessels are repaired, they must be dissolved to restore blood flow. This process, called fibrinolysis, is a small cascade that produces the enzyme plasmin. Plasmin cleaves fibrin and dissolves the clot. Because most clotting factors are produced in the liver and their production requires vitamin K, liver diseases such as cirrhosis and vitamin K deficiency may cause excessive bleeding. The main bleeding disorders, however, are inherited. These conditions are caused by gene mutations that lead to deficiency of a certain clotting factor. They are usually treated with replacement therapy, using purified factors produced by recombinant technology, or frozen platelets. While formation of blood clots is critical to control bleeding, inappropriate coagulation can be dangerous. In fact, far more people die from unwanted blood clotting than from clotting failure. Unwanted blood clot formation, known as thrombosis, is the most common cause of blocked arteries in heart attacks, strokes, and pulmonary embolism. Factors that prevent inappropriate coagulation include platelet repellent property of the endothelium, anticoagulant factors, enzymes that prevent clot formation, and the fibrinolysis cascade that dissolves blood clots after they are formed. Fluidity of normal blood flow also helps dilute the small amount of thrombin that forms spontaneously. Decreased flow or stagnation of blood may increase risks for thrombosis. People with high risks of unwanted blood clotting are treated with drugs that inhibit platelet aggregation, such as aspirin, or drugs that inhibit coagulation, such as heparin or warfarin.
Okay. So tapos na yung lecture natin. Joke lang. Hemostasis. Stop yung pag-flow ng blood. Okay? So these are examples of some bleeding disorders. Epistaxis. Ito naman, subconjunctival hemorrhage. This one, hemorrhagic stroke. Here is an aneurysm that can rupture. Okay? Ito naman, normal part ng menstrual cycle. Bleeding rin. Okay, so let's talk about platelets, also known as thrombocytes. Cyte meaning cell. Okay? Yan. This is a typical megakaryocyte that is seen with platelets budding off the periphery. The granular cytoplasm fragments from separate demarcation regions resulting in the formation of platelets. Okay. Function is for primary hemostasis. Maliit sila, 1 to 4 micrometers in diameter. Compared to your RBCs, na ano ng dimensions niya? 2 by 8 micrometer. They came from, or nanay nila, si megakaryocyte. And it fragments in the bone marrow or in capillaries. We have roughly 150 to 450,000 platelets per microliter in our blood. Okay, so less than 150, 150K, thrombocytopenia. Okay, more than 450,000, thrombocytosis. Yan. Lifespan, 8 to 12 days versus your RBC na 120 days. This one is eliminated by tissue macrophages, mainly in the spleen. Diyan din yung graveyard ng RBCs, di ba? Okay. Wala siyang nucleus, therefore it cannot reproduce. Okay. It has endoplasmic reticulum and Golgi apparatus, so it can create or synthesize proteins and store calcium. Whereas yung RBCs natin, wala nang organelles, no? So wala ring ER, Golgi, so it cannot make proteins, etc. We have here dense granules, mainly composed of ADP, calcium, serotonin, histamine, and alpha granules. Okay. So mononuclear, fibrinogen, fibronectin, and platelet factor 4. Nice to know. Merong mitochondria ang platelets, so they can produce their own ATP. They also have glycoprotein coat, okay, repellent to normal endothelium but sticks to injured endothelial cells. So pag bumabiyahe sila sa blood, kunyari, ito yung blood mo, andyan si platelet. Meron silang glycoprotein coat such that habang bumabiyahe, hindi sila didikit dyan. Okay? Because you don't want nga yung mga unwanted thrombus formation. Pero if injured yung certain segment ng blood vessel, dun siya didikit. Okay? Thanks to this one. Hinigyan tayo ni Lord ng glycoprotein coat. Platelets also have contractile proteins. Okay? Yan. So, ito sila. Pag na-activate, kakaroon ng cross-linking. Okay? Parang ready for action na ang activated platelet. How do you produce platelet? You call it thrombopoiesis. Parang sa RBCs. Paano sila? Erythropoiesis, diba? So, where do you produce one? Sa bone marrow. How long? 1 week. Okay? For production and maturation. Kaya pag naka-aspirin ka, naka-antiplatelet for years, for several years, tas o-operahan si patient, you have to wait for 1 week na para gumawa ng bagong platelets. Otherwise, pag hiwa mo dun, baka mag-bleed siya na mag-bleed, diba? Kasi wala pang platelets, naka-aspirin siya. Okay? This is regulated by thrombopoietin. Pag RBCs naman, si EPO from your kidneys, erythropoietin. Okay? TPO, or thrombopoietin, is secreted by the liver and kidneys. They stimulate megakaryocyte proliferation and maturation in bone marrow. Pag andyan si TPO, sinisigawan nila si megakaryocyte. Okay? TPO will come from the liver and kidneys. So, si kidney and liver. Pag kailangan na ng platelet, secrete sila ng TPO, tas si megakaryocyte ng bone marrow, gets niya na maggawa na tayo ng maraming platelets. Okay? Mag-bud off na ako nito. Yeah. Stages of thrombopoiesis include the following. So, myeloid precursor cell muna, then blast, then cyte, then platelet. Okay? Sige. Let's talk about hemostasis. This is a process involved in the formation of a platelet plug, okay, or yung white thrombus, following endothelial injury. Okay? Ba't ba nagkaka-endothelial injury? Siyempre, nasugat, napunit, yung blood vessel, etc. But the goal is to prevent further blood loss. So you have 4 mechanisms here of hemostasis. First one sa video, di ba? Vascular constriction. To prevent further blood loss nga. Then, formation of platelet plug, also known as primary hemostasis, followed by formation of blood clot naman, also known as your secondary hemostasis. Okay? Then, yung fibrous tissue mo, maka-convert into blood clot, which is permanent, etc. Okay. So here are the steps. No? Vascular constriction, which is due to local myogenic spasm. Nag-spasm, nag-contract yung smooth muscle sa blood vessel mo. Endothelin 1, this one is to prevent further blood loss. Primary hemostasis, tandaan na, primary platelet, PP. Okay? You're making platelet plugs here. Yan. So platelet would adhere to the blood vessel wall na damaged and adhere to other platelets na. Mediated by von Willebrand factor of ruptured blood vessel and GP1B of platelets. Pag-usapan natin later. Next, we have secondary hemostasis, SC, Supreme Court or Shopping Center. Secondary hemostasis, coagulation. You have 2 pathways, extrinsic, intrinsic, and meron pang common pathway. The goal is to make fibrin. Okay? Yung magsi-seatbelt sa mga platelets. Diba? Kailangan mo ng mesh dyan. Ayan. Fibrin mesh. To strengthen the loose platelet plug. Okay? Then, followed by resolution. Pwede mong lusawin yung clot if okay na. Okay? This is due to fibrinolysin, taga-lyse ng fibrin, or plasmin. So, let's watch how are platelets activated, okay? And the factors for clot formation.
In a first step towards clot formation, platelets are recruited to the site of vessel injury by now exposed molecules of the vessel wall, such as collagen and von Willebrand factor. This factor mediates the linking of platelets to collagen via a specific receptor in the platelet membrane. The resulting change of shape of the platelet from its resting state into the dendritic form indicates activation. The activated platelet in turn releases prothrombotic molecules, such as adenosine diphosphate, ADP. By binding to its receptors, ADP induces aggregation. And recruits further platelets to the site. Thromboxane is another important mediator of platelet activation and aggregation. Under its influence, the platelets cross-link with each other. These interlocking mechanisms cause platelet activation to snowball. The clot grows rapidly. Activated platelets also trigger the coagulation cascade and thus the formation of thrombin. Thrombin, in turn, stimulates platelet activation even further, a continuous feedback loop. Additionally, thrombin induces the formation of fibrin for the mesh stabilizing the clot. The self-reinforcing process of platelet activation, crucial in the formation of blood clots, is an obvious therapeutic target in conditions caused by inappropriately triggered blood coagulation.
Okay. So, let's talk about the first step in hemostasis. Okay? Vascular constriction. Pag may napunit, i-constrict mo. Otherwise, may butas dyan, maglilik yung blood. Okay? Again, this is due to local myogenic spasm and endothelin 1. Okay. Yan. There are also local vasoconstricting autocoid factors nag-act sa sarili mo. Okay? Endothelin 1 from injured endothelial cells and thromboxane A2 from platelets. Nakita nyo to from the video, right? Nag-release ng yellow granules si platelets. Thromboxane A2 yun. Okay? To promote vascular constriction. Yung blood vessel na napunit, sumisigaw din yan, no? Ng or nagsisecrete din ng something, which is endothelin 1 to promote vascular constriction nga. Okay? Just note, thromboxane A2, si TXA2, galing sa platelet, pampaano? Pang-constrict ng blood vessel. Endothelin 1, galing sa endothelium, lining ng blood vessel mo, na pampaano? Promote ng vascular constriction as well. What else can promote vascular constriction or vasoconstriction? Nervous reflexes. Okay? Next, formation of platelet plug na loose, no? Wala pang fibrin eh. So, primary hemostasis yan. Okay? This is mediated by von Willebrand factor of ruptured blood vessel, walls, and GP1B of platelets. Okay. Alamin nyo kung nasan yung von Willebrand factor and na kanino yung GP1B. Okay? Para siyang lock and key. Okay? Ito yung doorknob, ito yung susi. Tapos magdidikit sila. Para si platelet makapara. Imbis na mag-swimming sa bloodstream mo, ma-lock siya dyan, didikit siya dyan. Okay? Yan. So, primary hemostasis. So, si platelet natin, nagsiswimming sa bloodstream. Okay? May mga antena-antena siya dyan. Yan. Maraming glycoproteins. Once na-spot niya, uy, punit. Anong gagawin? Anong gagawin natin? Para po. Okay, hihinto si platelet. But first, anong gusto mong gawin? I-vasoconstrict, diba? So, nag-release si platelet ng thromboxane A2. Si endothelium naman nag-release ng endothelin 1 para mag-vasoconstrict. Next step, gusto niya nang tumigil. Okay? Para. So, yung na-expose na subendothelial collagen, no? May von Willebrand factor dyan. Okay? Yung green. Yung von Willebrand factor, dumidikit sa glycoprotein 1B ni platelet, GP1B, para huminto, para magpara si platelet. Hindi lang siya swimming. If wala siyang GP1B, hindi yan didikit sa blood vessel. Okay, na may exposed na collagen, subendothelial collagen. Okay? Subendothelial, nasa ilalim ng endothelium. Okay? Pag hindi naman punit yan, hindi ma-expose yung von Willebrand. Thanks to von Willebrand factor ng lining ng blood vessel and GP1B ng platelet, nagdikit sila. Okay? So, may migration and rolling na nagaganap-ganap pa dyan. Okay. The goal is to form loose platelet plug, also known as white thrombus. So, ito yung steps sa primary hemostasis. Dumikit ka, adhere, then activate mo si platelet, then aggregate. Okay? Dumikit ka muna, mag-adhesion ka sa lining ng blood vessel, ma-trigger ka, ma-activate ka na, mag-release ka na ng kung ano-ano, okay, as saklolo or signal to other molecules and to the blood vessel, and dumikit na kayo, magdikit-dikit na sa isa't isa. Ito dumikit sa blood vessel, ito nagdikit sa kapwa platelets. Okay? So, here in platelet adhesion, the trigger is collagen exposure, no? Collagen in injured endothelium. Yan. So, subendothelial collagen binds to platelet. Platelet swells and becomes more stickier. Okay. Von Willebrand factor is released from injured tissue and binds to exposed collagen. Okay. Then, platelet binds to von Willebrand factor via GP1B. Then, platelet changes shape. Kuha nyo. Ulit. So, subendothelial collagen, na-expose siya, didikitan ng von Willebrand factor. Then, yung von Willebrand factor na yan, kung doorknob siya, ang susi ay GP1B. Nino? Ni platelet. Okay? Ni platelet. Yun lang naman. Tapos, pag dumikit na si platelet dyan, hindi na siya maaanod or sasabay sa daloy ng dugo, no? Platelet changes shape. If you don't have, sakit agad no? If you don't have GP1B, yung platelets mo walang GP1B, hindi yan didikit sa sa exposed na punit na blood vessel. Okay? The patient will have Bernard-Solier syndrome. If wala ka namang von Willebrand factor, von Willebrand disease, yung sakit. Okay? So, ma-expect mo na kung may bleeding dito, hindi dumidikit yung platelet. Okay? Next, platelets will release the following. Okay? Yung mga saklolo. Calcium, necessary for coagulation cascade. ADP, that helps platelet adhere to endothelium. And then thromboxane A2 na nakita nyo na, which promotes vasoconstriction. Okay? So thromboxane is a vasoconstrictor, and along with ADP and platelet activation factor, platelet activating factor, si PAF, it acts on nearby platelets to activate them as well. The stickiness of these additional activated platelets causes them to adhere to the original activated platelets. Ano daw? So, ang goal mo kasi, dumikit ka sa punit na lining and dumikit ka sa kapwa mo. Okay? Paano yan? Paano magsasabi yan? Ano ba i-release nito? Release sila ng parang magic sarap. Isa doon si calcium para ma-trigger ang coagulation or ma-help stimulate yung coagulation cascade later. Kailangan kasing calcium doon eh. Isa doon si ADP that helps platelets adhere to endothelium. Uy, tulungan mo dumikit doon. And thromboxane A2 na sinisigawan si blood vessel na mag-vasoconstrict. Okay? And platelet activating factor. Pang-activate sa kapwa niya platelet. Yan. ADP binds to P2Y12 receptor. This one induces GP2B3A expression at platelet surface. Lo, di naintindihan. Ulit. ADP will bind to P2Y12 receptor. Okay? Tapos, pag dumikit si ADP dyan, yun, nag-release to ng magic sarap na si ADP. Pag dumikit yan sa P2Y12 receptor, yung tinatago mong alindog, ang tawag doon glycoprotein 2B3A, ilalabas. Okay? Nakatago kasi sa loob eh. Ilalabas sa surface ng platelet. Para saan ba yung 2B3A na yan? Para dumikit sa kapwa platelet. Hindi sa blood vessel sa kapwa platelet. Kapag may fibrinogen na sa pagitan nila. Okay? Fibrinogen binds GP2B3A receptors and links platelets. So remember that, ha? Sino yung nasa platelet? Sino yung nasa subendothelial collagen? Sino yung nasa loob muna? Paano ilalabas? Okay. So again, adenosine, didikit here. Lalabas na si 2B3A, ang tinatago niyang ganda. 2B3A, yan yung didikit sa kapwa platelet if may fibrinogen na. Okay? If you don't have 2B3A, Glanzmann thrombasthenia, ang sakit. Some drugs will block this. Some drugs will block that. Thromboxane, iba-block ng aspirin. What the drugs? Sige, nice to know for now. Pagdating nyo na lang sa pharma. Okay? Yan. So, aggregation of platelets, glycoprotein 2B3A receptors are bound by fibrinogen, forming bridges between adjacent platelets. Sabi, huy, magbati na kayong dalawa, platelet 1, platelet 2. Patingin nga ng mga sungay nyo, 2B3A nyo, akin na, sabi ni fibrinogen. Okay. So, these are pro-aggregation factors, thromboxane, decreased blood flow. Syempre, pag mabilis yung blood flow, hindi makakapara si platelet, di ba? Just go with the flow lang yan para sa splash island. And increased platelet aggregation. Ito naman, magbe-bleed ka if may prostacyclin or PGI2, nitric oxide na vasodilator, and sobrang bilis ng blood flow, binabaha na, hindi makadikit, makapara si platelet, and decreased platelet aggregation. Okay? Yan. Platelet party. B1 at B2. Dikit sila. Platelets. Anyway, let's recap. So, we have here endothelial damage, and there will be transient vasoconstriction via neural stimulation or endothelin 1. Nan-release nino? Ni damaged blood vessel. Okay? Then, exposure. Von Willebrand factor binds to exposed collagen. So, von Willebrand factor is from WP bodies of endothelial cells and alpha granules of platelets. Pero dito siya didikit sa exposed collagen ng blood vessel na napunit. Platelets binds von Willebrand factor via GP1B. GP1B nasa platelet, tandaan. At the site of injury only. Specific siya. Hindi pwedeng pumara o dumikit si platelet kung wala namang sugat, no? Platelets undergo conformational change. Then platelets will release magic sarap, mga granules. It will release ADP and calcium. Calcium is needed for coagulation cascade. ADP para saan? Para ilabas ang tinatagong ganda, ang glycoprotein 2B3A niya. Thromboxane A2 as well for vasoconstriction. Okay? ADP helps platelets adhere to endothelium. Okay? Then activation. ADP binding to P2Y12 receptor induces tinatagong ganda expression at platelet receptor, 2P3A. Si tinatagong ganda, si glycoprotein 2B3A ay pang-connect sa kapwa platelet. If meron silang sinandwich na fibrinogen. Okay? Fibrinogen binds glycoprotein 2B3A receptors and links kapwa platelet. Tandaan na. Von Willebrand factor, platelet to endothelium. Fibrinogen, platelet to platelet. 2B3A, platelet to platelet. Platelet. Anong tawag pag ang platelet mo late dumating? Platelet. Anyway. Then, temporary plug stops bleeding, but it's unstable, easily dislodged, pwede mapatalsik yung clot na yan. So, kailangan mo ng secondary hemostasis para i-reinforce ang platelet plug mo. Okay? Seatbelt mo sila. May fibrin dapat. Okay, let's talk about your secondary hemostasis. Kanina, nag-form na tayo ng platelet. Enough na ba yun? Hindi pa. Kailangan may fibrin. So, fibrin appears, fibrin clot forms, and clot retraction occurs. Pag okay na. Okay. So, secondary hemostasis refers to blood coagulation or clot formation. Here, yung fibrinogen, ang goal mo, fibrinogen should be converted to fibrin. Yan. And to stabilize, because fibrin yan yung mesh that will stabilize the platelet plug, leading to your red thrombus or clot formation.
At the site of vessel injury, the first platelets arrive to start sealing the wound. Simultaneously, the coagulation cascade with its various coagulation factors is activated. This involves two pathways, the extrinsic and the intrinsic pathway. Extrinsic activation begins with now exposed molecules of the vessel wall, such as tissue factor, which forms a complex with factor 7. Finally leading to the activation of factor 10. This factor 10A is the point at which the extrinsic and the intrinsic pathways of the coagulation
Kita nyo, tissue factor, also known as factor 3, pinatungan nino ni factor 7. 7 plus 3, 10. So, 10 ang susunod, factor 10.
Cascades meet. The intrinsic pathway consists of various coagulation factors activating each other in a chain reaction. At its end, a complex with an additional cofactor is formed. This complex now activates factor 10. Since the two pathways merge at the level of factor 10A, this factor has a pivotal role in the coagulation cascade. Further down the cascade, factor 10A, in combination with 5A, activates thrombin and induces the so-called thrombin burst. One molecule of factor 10A can catalyze the formation of 1,000 molecules of thrombin. These large amounts of thrombin cause the further activation of platelets and the enhanced formation of fibrin. Fibrin then forms strands, making up the mesh that stabilizes the platelet plug in an arterial clot.
Recap lang ah.
It can be concluded that the central role of factor 10A in the coagulation cascade makes it a viable target for therapeutic intervention in pathologically altered blood coagulation. Formation of fibrin.
Blue, sino yan? Thrombin. Factor 2. Inano niya, chinever niya si fibrinogen, ginawang fibrin.
Fibrin then forms strands, making up the mesh that stabilizes the platelet plug in an arterial clot and holds together the red blood cells in a venous clot. It can be concluded that the central role of factor 10A in the coagulation cascade makes it a viable target for therapeutic intervention in pathologically altered blood coagulation.
Okay. So, secondary hemostasis na tayo. So, there's, again, rupture of the blood vessel or damage to blood itself leading to coagulation cascade. Okay. Wherein your goal is to convert prothrombin to thrombin. Kasi thrombin, yung blue, siya yung mag-convert ng fibrinogen to fibrin. Yung tali, yung mesh, no? Para stabilize mo ang platelet plug. So clotting takes place in 3 essential steps. Number 1, in response to rupture of the vessel or damage to the blood itself, a complex cascade of chemical reactions occur in the blood involving more than 12 blood coagulation factors. The net result is the formation of a complex of activated substances, collectively called prothrombin activator. Okay? The prothrombin activator catalyzes the conversion of prothrombin into thrombin. Then thrombin acts as an enzyme to convert fibrinogen into fibrin. So fibrin fibers that will enmesh platelets, blood cells, and plasma to form the clot. Okay, daming pinagdaanan, no? Tapos tutuklapin mo lang yung sugat mo, yung scab. Anyway, what is the process that leads to stabilization of the platelet plug, also known as the white thrombus, by creating a fibrin network? You call it your coagulation cascade, okay? Again, it's a sequence of events triggered by the activation of the intrinsic or extrinsic pathway of coagulation that results in the formation of a stable thrombus. Ang goal mo sa coagulation cascade, maging what? Ma-activate si thrombin and then thrombin will cleave fibrinogen to fibrin, okay? Yan. So here you have coagulation factors. These are substances that interact with each other to promote blood coagulation. Activated factors are designated with an A. Okay, may letter A. So, si 7 naging 7A, it means activated na siya, si factor 7. 10 becomes 10A, na-activate na si factor 10. Okay? Coagulation factors are mainly synthesized by the liver. So, if na-compromise mo yung liver mo, nasira, for instance, may cirrhosis si patient, you'll expect na may bleeding tendencies siya, no? Kasi hindi nga nakagawa ng coagulation factors, liver mo. So, here are the pathways. You have extrinsic, intrinsic, and common pathway. The intrinsic pathway responds to spontaneous internal damage of the vascular endothelium, whereas the extrinsic pathway becomes activated secondary to external trauma. Okay? Both intrinsic and extrinsic pathways meet at a shared point to continue coagulation, so this is called the common pathway. So again, intrinsic pathway activated by factors in the blood. Okay, intrinsic sa dugo. Pag na-activate siya dahil sa kasalanan ng blood vessel or blood mo, intrinsic. Ang extrinsic naman, it's activated by tissue factor. Okay? Extrinsic, external trauma. Hindi naman kasalanan yung blood vessel, nanahimik siya, tapos may something na-activate tuloy. Extrinsic pathway yun. Okay? Next, what are the factors in extrinsic pathway? Extrinsic. So, may mnemonic tayo here later. So, you have factor 7. Kita nyo sa video, di ba? And si tissue factor, factor 3. Okay? So, 7 plus 3, 10. It will lead to factor 10. Yan. Yan yung extrinsic pathway. Ang intrinsic naman starts off with factor 12, 11. Yung 10, andito na sa gitna. So, skipan mo. Then, 9. Okay? Si 10, ano bang mga i-multiply natin to get 10? So, it's 5 times 2 times 1. So, factor 5. After ni factor 10 ma-activate, i-activate niya si factor 5. Factor 5 will activate factor 2. So, magiging thrombin yan. And factor 2 will activate factor 1, also known as fibrinogen, to become fibrin. O, ganun lang. Dok, asan si 13? Andito siya. Pag-usapan natin later. Okay? So, here are the synonyms or other names of your clotting factors. Tandaan. Joke lang. Factor 2 is thrombin. Factor 1 is fibrinogen. Factor 3, tissue factor. Sino pa? Factor 8 is anti-hemophilic factor A, A8. Factor 9, anti-hemophilic factor B, B9. Okay? Factor 9, mukha siyang Christmas tree, oh. This is the Christmas factor. Factor 10, Kristen Stewart. Kilala mo yun, si Kristen Stewart ni Edward. Diba siya si Bella? Anyway. Factor 12, Hageman factor. 12. What else? Factor 13 is fibrin stabilizing factor. Siya yung nang-stabilize ng fibrin into cross-linked fibrin. Okay. So, you have to memorize or familiarize, no, yung mga other names. Factor 4, hindi ko nakita si factor 4, Doc, ah. Factor 4 is calcium. Diba, makita niyo si calcium kanina sa may platelets. Pinag-usapan natin. Ni-release kasi involved nga siya sa coagulation cascade. Okay? Extrinsic pathway of coagulation, the trigger here is tissue factor. Pag na-trauma, because of extrinsic causes, nasira blood vessel mo, si tissue factor ang ma-activate first. Okay? Factor 3. This one is from injured endothelial injury after external damage. Then factor 3, ano i-add mo para maging 10? Si factor 7 naman i-activate niya. So, tissue factor from subendothelial muscle cells and fibroblasts. Factor 7 is a vitamin K-dependent coagulation factor produced by the liver. Okay? Factor 7A, na-activate na. And tissue factor form a complex tissue factor, factor 7A complex. This one requires calcium found on the surface of fibrocytes and activated platelets. Kaya sabi ko, diba, yung calcium kailangan later sa coagulation cascade. Si 7 at 3, magkadikit if may calcium. Okay? Requires calcium. Then, this complex will activate factor 10 and factor 9. Okay. Let's talk about intrinsic pathway. Intrinsic, so 12, 11, skipan mo yung 10 kasi nasa gitna nga yun, 9. Okay. Okay, intrinsic factor. Here, the exposed collagen, kallikrein, and kininogen, or HMWK, will activate factor 12. Okay? Intrinsic, yung nangyari sa blood vessel mo mismo. Factor 12, also known as Hageman factor, it's a coagulation factor that plays a role in inflammatory response by activating kallikrein system, which leads to the production of bradykinin. Anyway, commercial lang. Factor 12A will activate factor 11. Okay? Then, pababa na yan. 11, skip again yung 10 ha, kasi dito nga siya, common pathway. Si 11 activate si factor 9, etc. etc. Hanggang 5, 2, 1. Okay? So, thrombin activates factor 11 and 8. Okay? Tandaan. So, si thrombin, i-activate niya si 11 and si 8. Yan. So, para siyang loop. Factor 11 activates factor 9. So, ito na yun. 11 activates factor 9. Factors 8A and 9A form a complex mediated by calcium that activates factor 10. Yun. Okay? So, si 9 and ulit. So, si factor 11, i-activate niya si 9. Tapos, factor 8 and 9, si 8 and 9 didikit to form a complex. Dinikit sila ni calcium that activates. Yung triplets na yan, i-activate si factor 10. Okay? This causes a positive feedback loop of factor 10 and thrombin activation via the intrinsic factor. So, i-activate niya ulit yan eh. Okay? Next, we have the common pathway. So, again, 10. Ano yung mga ita-times mo para magka-10 ka? 5 times 2 times 1. So, after ma-activate ni factor 10, si factor 5 naman, then factor 2, and finally fibrinogen. So, here, factor 10A and 5A form a complex mediated by calcium that cleaves prothrombin or factor 2, papuntang thrombin or factor 2A. Oh, di naintindihan? So, si factor 10 activated and si factor 5 mag-combine mediated by calcium. Yung combination na yan, yung mag-activate kay prothrombin, factor 2, papuntang activated form niya. Ito si 2A. Okay? Then si thrombin, siya na yung mag-cleave ng factor 1, papuntang fibrin. So, thrombin cleaves fibrinogen or factor 1 into insoluble, di nalulusaw sa dugo, insoluble fibrin, also known as factor 1A monomers. Crosslinks of the fibrin network are stabilized by factor 13A. Andito si 13. Okay? So, pag dikit-dikit mo yan, isa-stabilize yan ni 13. Hindi yan lala ha, 1A, 1A. Yan. So, formation of a fibrin network na. Fibrin closely binds to the platelet plug, forming a stable thrombus. Okay? Thrombus na. So, si platelet plug na may fibrin seatbelt, tawag doon thrombus. Secondary thrombus or red thrombus. Okay? Pag tumasik yung thrombus, embolay yun. Embolism. So, again, extrinsic factor, si tissue factor, ano i-add mo para magka-10. Yan. Ito naman, pababa, 12, 11, skipan mo yung 10 kasi nasa gitna na nga, 9, okay? So, complex mo ng calcium yan, and 8, etc. Then, common pathway, ano yung mga times mo para magka-10? So, 5 times 2 times 1. And ito, nagluloop, diba? Nagluloop. Anyway, so how do you check for integrity of intrinsic pathway? You order PTT. Extrinsic pathway, paano mo malaman kung intact pa? You order PT. Kung common pathway ang gusto mo i-check, order both. Okay? So, mnemonic, again, intrinsic, pababa lang. 12, 11, 9, 8, etc. Extrinsic, yung mga i-add mo para magka-10. Pack. Tapos sa baba, common pathway, multiples ng 10. Multiples ng 10. May mga ita-times mo para magka-10. 10 times 5, 5 times 2 times 1. Okay? Yan. Recall. Intrinsic pathway is activated by subendothelial collagen. Okay? Extrinsic pathway is activated by tissue thromboplastin. Then we have the mnemonic 1972 wept. Anyway, ano daw? So, factors 9, 10, 7, and 2. Saan nakikita yun? Factors 9, 10, 7, and 2. Saan nakita si 9, si 7, etc. Anong mnemonic mo dyan sa 1972? W stands for warfarin, extrinsic, and PT to check. 1972 plus protein CNS. These are your vitamin K dependent coagulation factors. So, kailangan nito ng vitamin K. If you lack vitamin K, ano mangyayari sa'yo? Di may bleeding din. Okay? Kaya nga binibigyan yung mga preterm ng mga vitamin K. Okay? Mga newborns. So, vitamin K is needed for blood clotting. Newborn babies are given vitamin K injections to prevent a serious disease called hemorrhagic disease of the newborn. Puputok-putok yung sa utak nila. So, again, vitamin K is needed by these coagulation factors. No? Factors 9, 10, 7, and 2. Tapos si protein CNS. Warfarin will block that. Anyway. 9, 10, 7, 2 are vitamin K dependent. Warfarin acts on extrinsic pathway and PT is used to check it. Si heparin naman sa intrinsic nag-act. And PTT to check it. These are the other names of your coagulation factors. Favorite natin, of course, si factor 1, 2, ano pa? Baka si calcium din. Christmas factor, madali lang yan eh, 9. Parang Christmas tree ito. Okay. Kristen Stewart is 10. Hageman is 12. Yun lang naman mga favorite natin. So, for the common pathway of coagulation, saan nag-start? Ulit. Factor 10. Okay? So, factor 10A and factor 5A form a complex mediated by calcium that cleaves prothrombin, factor 2, papuntang thrombin or factor 2A. thrombin cleaves fibrinogen or factor 1 into insoluble fibrin, also known as factor 1A. Crosslinks of the fibrin network are stabilized by factor 13A. Formation of a fibrin network to fibrin closely binds to the platelet plug, forming a stable thrombus. This is your secondary thrombus or red thrombus. Diba? Ang daming pinagdaanan, no? So, 10. Saan magbabind? Factor 5. Sino maglilink sa kanila? Calcium. Tapos, ang gagawin nila? Si 2 gagawing 2A. Prothrombin gagawing thrombin. Ang gagawin nito, fibrinogen gagawing fibrin. Okay, so known as factor 1, si fibrinogen. Tapos, maraming fibrin. Oh, sino magtutulong-tulong dyan? Magsastabilize. Factor 13. Fibrin 13 para stable siya. So, platelet plug plus fibrin, thrombus na yung tawag dyan. Okay? So, ang daming pinaghirapan ng platelets mo and ng coagulation factors mo. Tapos, pag may scab yung sugat mo, ano'y mo lang, tuklapin mo lang. So, it's some kind of evilish. Charot. Evilish. Anyway, ito, huwag nyo nang titigan to. Basta, 12, 11, alam nyo na yan. Okay? So, there are some drugs that will inhibit thrombin. Ang tawag doon, antithrombin. Diba? Ano pa? Plasminogen will be converted to plasmin via this one. That will block clot formation. Basta alam nyo lang yung coagulation cascade. And pag binigyan ka ng drug when you go to pharma, this drug inhibits blah blah blah. E di, compromise yung coagulation mo. Okay? Hageman. Dozen, please. Hageman. 1 dozen. 12. 3 plus 7 equals 10. Ito, 5 times 2 times 1 equals 10. Fibrin is the first or factor 1. Si plasmin, lulusawin si fibrin. Fibrin, pag nilusaw mo, ang panglusaw is plasmin. Ang pang-enhance IC, factor 13. Factor 7 has the shortest half-life. Factor 2 has the longest. Longest half-life. Okay. So, again, there will be drugs that will block each step of your coagulation cascade. So, we have here your anticoagulants, low molecular weight heparin, direct 10A inhibitors. Bakit mo pinagtitripan si 10A? Kasi siya yung nasa common pathway, di ba? So, we have here apixaban, fondaparin. If you lack factor 8, ang tawag sa'yo hemophilia A, A8. If you lack factor 9, B9, hemophilia B yan. Factor 11, kulang ka doon, hemophilia C. Okay? You also have regulatory anticoagulant proteins. Ito, pro-bleeding sila. Ayaw nila mag-coagulate ka. So, you have your protein C and S. Mga anticoagulant, mga pro-bleeding din. Bleeders, heparin, low molecular weight heparin, direct thrombin inhibitors. Ito si factor 2 ang kinakalaban. Yung second to the last step. So, kung gusto mo kalabanin si thrombin para hindi tumuloy yung fibrinogen to fibrin, bigyan mo ng argatroban, bivalirudin, dabigatran. Okay? What else? However, kung naging fibrin pa rin, tapos nagkaroon ka ng fibrin mesh na stable na, you can degrade it. Okay? Leading to fibrin degradation products. For instance, D-dimer. Sinong gustong manglusaw niyan? Yun nga, plasmin. Ayaw mo na kay fibrin mesh, edi de-degrade yan ni plasmin. Saan galing si plasmin? Kay plasminogen na kinonvert ni TPA, tissue plasminogen activator. Anyway, si plasmin pampalusaw. Plusaw, whatever. So, plasmin breaks down the fibrin meshwork of the formed clot and allows for recannulation of blood vessels. TPA and urokinase are derived largely from the endothelium and released upon activation or injury. The effects of plasminogen are decreased by PI1, endogenous plasminogen activator inhibitor. Siyempre, inhibit na si plasmin. Okay? Another name ni plasmin, fibrinolysin. Kasi nilalize na si fibrin. It's a non-specific protease present in human serum, responsible for degrading a variety of plasma proteins. Okay? Its specific physiologic role is to degrade fibrin clots. Fibrin lulusawin ni plasmin. Kaya pag sinulat mo yan, no? PLS, pampalusaw. Okay? If ayaw mo magka-plasmin, di kalabanin mo si TPA, yung nanay niya. Okay? Bigyan mo ng tranexamic acid. Ito yung sa mga, for instance, nag-epistaxis, yung tita mo, dugo ng dugo yung ilong. Aside from ipipinch mo to promote vasoconstriction, bigyan mo ng tranexamic acid. Si Tranex, i-inhibit niya tong nanay ni plasmin. So, pag wala si nanay, si TPA, wala rin si plasmin. So, stable pa rin yung fibrin. No? If gusto mo naman duguin, hindi promote mo si TPA. When would you like that? Kapag may mga stroke, yan. So, you can give streptokinase, alteplase. For instance, may thrombus, lumipad dun sa blood vessel sa utak. You wanna lusaw that. Go tita. Go TPA, di gagawa ng maraming plasmin, lulusawin yung fibrin. Kung yung stroke ay humarang dyan, tas nalusaw, kasi binigyan mo ng TPA, activator or pro-TPA, malulusaw na yon. So, ayan na. Makaka-flow na ulit yung dugo. Okay, 10 points ang quiz na to. 2 points for this one. 2, 4, 6, 8, 10. Okay? So, sagutin nyo. Extrinsic pathways initiated by factor blank. Intrinsic pathways initiated by factor blank then. Forms factor 2A that converts blah blah blah. Ano yung meshwork that strengthens the loose platelet plug? Answer and send it to my email within the day to prove that you watched this video. If you don't send it within the day, if I don't receive it, it means hindi ka nanood and 0 ka sa post-test. Okay? Thank you.